Welcome back. In last part I discussed about the visible light. Now in this after visible light we can see from here the UV. So let me start with the UV or ultraviolet. Why the name is ultraviolet? Because it is after VIBGYOR, right? The wavelength is decreasing in this order. So why this is infrared? Infrared because the wavelength is greater than red. Red light has the wavelength around 700 nanometer. So in case of infrared, the wavelength is bigger than the red light. That's why it called infrared. And the violet color has the wavelength 400 nanometer, and ultraviolet has the wavelength less than 400 nanometer. That's why it's called the ultraviolet. Okay. So what is the wavelength? It should be less than 400. So it is 4 into 10 to the power minus 7 meter to 6 into 10 to the power minus 8 meter. This is the wavelength. Okay, so what is the source? Also, due to the electronic transition, UV the emitted electromagnetic waves also resides in the ultraviolet region as well. Here you can say now we have said that the visible light also for ultraviolet, this is the source, ultraviolet region, this is also the source, the inner cell electronic transition, right? Or also the sun, from sun rays, that is also the main source for electromagnetic for UV rays. Okay. Detection. Photocells, again photographic films, and uses. Okay, in visible light I did not mention the uses. So most main use of the visible light is our world, we can say. Our world is totally colorful due to these visible lights. So this is the main use of, we can say, that for visible light. And one more thing that is important, our eye is more sensitive to the yellow color. Okay, more sensitive, yellow, mainly yellow, or we can say some green part, but mainly the yellow color, the wavelength is 5.5, so it should be 55500. Okay, 5.5 into 10 to the power 5 meters, that is exact the mean of these two things. Okay, so our biological eyes is maximally sensitive to this yellow light. Okay, uses of the UV. Production of vitamin D in our skin, and also cure some skin disease like vitiligo. These skin diseases are also cured by UV rays. Okay, and UV rays also uses in electronic spectroscopy. Okay, next after UV it is X-ray. First is the wavelength. It should be lower than the UV, so it's 6 into 10 to the power 8. So we can say roughly for X-ray, it is 6 into 10 to the power 8 meter to 10 to the power minus 11 meter. So this is the wavelength. And source, what is the source? We know from the experiment of Röntgen, right? Röntgen experiment, how the X-ray was first time detected. That's why it was called the X-ray, because it was totally new kind of wave or radiation. That's why it was called X-ray. Okay, we know that. So we can write it here. When a stream of electrons, which is essentially the cathode ray, with high kinetic energy, is incident on a metal surface. In X-ray tube, it is actually produced. And how it was detected? Detection is also in photographic plates. J tubes, ionization chamber. Okay, so these are the detection and uses of X-ray. We very much aware of the uses of X-ray. Okay, X-ray are basically very much used in our medical science. So let me write it. Uses to identify the bone structure, so its use is medical imaging, and also its use as therapy to treatment like cancer. Okay, so these are the main, basically the medical purpose. In medical purpose, we extremely use X-ray. X-ray used in the which kind of spectroscopy in X-ray? X-ray is generally to detect the electrons. So we can say most bare spectroscopy is used, gamma ray exactly. Okay, so let me think what was the uses of X-ray. Yes, here. Okay, here it was electronic spectroscopy, small sphere spectroscopy, gamma ray used in small sphere spectroscopy, XRD, right? X-ray used in XRD. XRD is there, X-ray detection to detect the structure of solid items, solid states. So XRD used in those cases. Okay. Next, the last one is gamma ray. Okay, so what is the wavelength? It is 10 to the power minus 11 meter to 10 to the power 14 meter. This is the wavelength. Okay, and what is the source? Radioactive substance. We have studied in radioactivity, right? The radioactive substance emits the alpha ray, beta ray and gamma ray. This is that gamma ray. Alpha ray and beta ray are not included in electromagnetic waves because those are the flows of the particles. Alpha ray is generally alpha ray is the flow of helium-2 plus ions and beta ray is flow of the electron. But gamma ray is actually totally flow of a neutral particles, we can say that, which is photon essentially, and that is a part of our electromagnetic radiation spectrum. So radioactive elements. So we can say this is a gamma ray is one of the constituents of cosmic ray. So actually gamma ray is also a cosmic ray. We differently tagged it as gamma ray. After that, after gamma ray there is no different name. Those all are the cosmic rays. Okay. This is the source, the detection. The same detection in case of X-ray. What was the photographic films, ionization chambers. Okay, this is the detection uses. This is also used in medical purposes. We know this also. Also used in scientific investigation. And okay, and the spectroscopy. Mossberg spectroscopy. In Mossberg spectroscopy it is used. I am not sure about the spelling, but it is Mossberg spectroscopy. Okay, this is the gamma ray. Uses of the gamma ray. So these are the all spectrum. I am not there is no specified region for the cosmic ray. After gamma ray everything is called cosmic ray. Also gamma ray is also part of the cosmic ray, but still you can say that. Okay, so this is the total electromagnetic spectrum of our electromagnetic radiation. Nothing else. Now we should do some numerical problem, not numerical problem, some problems and some important question like first question is why use of satellites is necessary for long distance TV transmission. Okay, because waves of high frequency is necessary. Okay, let me write down the question first. Why uses of satellites is necessary for long distance TV transmission. The answer is waves of very high frequency necessary for long distance TV transmission, because that should be should be traveled into the ionosphere, and that's why the for that we need the high for why okay, that's why we need the satellites, uses of satellites. Let me write it clearly. Waves of very high frequency is necessary for long distance TV transmission, which is get through the ionosphere, right? And that's why the satellite is used. to return okay. So there are many other questions. So one of the important question is this. So let me ask some important question. Okay, so the source of electromagnetic wave can be a charge moving with a constant velocity, a charge moving in a circular orbit, a charge at rest or falling in an electric field. This answer is very easy, because we know that for electromagnetic radiation there must be oscillating electric or magnetic field. So it should be a charge which can present in a electric field, or it may be moving in a circular orbit. So these are important numerical important questions are there, but I'm not going to that part. Let me state nothing left. Basically the chapter is almost completed. So let me end it by giving the summary of this class. In this class we basically studied the detailed spectrum of the electromagnetic waves from radio to cosmic. Okay, and also we have studied the uses, source of those spectrum and the detection. So nothing left. Also we have discussed the previous parts at starting. Let me end this course by drawing again for the last time the electromagnetic waves. In this y axis there is magnetic field, not this color. So this is our electromagnetic wave. Okay, so I don't think anything left. I have discussed all the important topics of this chapter, electromagnetic waves. So I think you have also enjoyed this course. So let me stop. Thank you for this course. Thank you very much.